Oh, hi guys. I'd like to talk a little bit about this Kirchhoff rule. Since I detected that you had some problems to do exercise number 5 from the homework I sent the other day, I hope by reviewing these rules, maybe next time you are not going to have any problem. So, Kirchhoff, Kirchhoff rules we apply when we have circuits, and usually when we have what you call loops. Like in here in this example we have two loops, and the first thing we do, we find the junction, and we we note we denote all the current that is going through any of these parts in these wires, and the junction, this you have to the current is conserved. It means that for example in here the the current number I3 is equal to I1 plus I2. Okay, so this is the first loop. Like at any junction point, the sum of all the currents entering must be equal to the sum of all the currents leaving the junction. Okay, and the second rule is the loop rule. That basically you have to see that the sum of all the sum of the change in potential among any closed loop of the circuit must be zero. Must be that you have to compute uh, the the voltages in this loop, and then the voltage in this loop, it has to be zero. You have to first you have what you have to decide is the direction of the current. Just pick any. Like for example here we pick it clockwise, but bear in mind that if you pick it clockwise in here, means that from D to A, the direction has to be like this. So in this loop, you have to pick it counterclockwise. Okay, so you don't have any sign problem. Okay, so what does it mean that the sum of all the potential are in one loop, it has to be zero? The change of the potential loop is zero. So for example, you check this loop. This loop we have this the differential potential is given by this battery. So we pick like before, like the current goes this way. So this 12 volts must be equal to the current that passes through this line is the same. So it has to be 12 minus the current multiplied by the resistance, the voltage, minus, because it drops potential, the resistor drops potential, so, and also here uses some potential, so this IR minus this IR in here, and it has to be equal to 0 in here. Okay, we can see it in this one. So it's the 12 volts has to be consumed by these two resistors. Okay, so the current is going to adapt. Okay, so this is the table you should read and memorize to solve this kind of problem. And so first you need to label all the currents in all these lines. You have to check what you know. So the first rule you apply is the junction rule. You check that all these currents they add up in the junctions, and then you apply the loop rules. Okay, so in this case we have like for resistor, you have that voltage is equal the in current that is passing, and times the resistance, and it has to go is the sign is the opposite of this of the current, the sign of the current that is passing that line. Okay, because it's dropping potential. And for the battery, if it's the battery I didn't say, but you see, if the current goes this way, is adding. Okay, it goes from minus to plus. It's usually respecting it has the same sign as the current passing. Okay, So this usually is if it's like from minus to plus, is adding. If it's from plus to minus, subtracting. And finally, you are going to reach hopefully as many equations as unknowns, and you can solve it. Okay. One example is this is the problem I gave you the other day. There was the problem number 5 in the homework, and here you can see we have several uh, batteries, several power sources here, and we pick the direction. Like there are actually 3 currents. There are 2 loops, 1 and 2, and 2 currents, 3 currents. Sorry, I1, I2, and I3. So this we note them, we write them down, and now we start applying the Kirchhoff rules. So it's what it says in here. Well, you can check that I3 is I1 plus I2, right? This you check this junction A. I3 is I1 plus I2, and then you start doing the loop. So I guess you follow the direction of the current. So this loop is counterclockwise, and this loop is clockwise. Okay. So we first arbitrarily choose the left-hand loop, start at point B, start at point B, and you look. Oh, sorry, they pick clockwise, so they pick it like this. So you have sorry. I miss the loops. The left-hand loop still. Sorry about it. And they pick crosswise. So yeah, that's what I'm saying. So they start in point B. So this I1 times R1 minus, because it's following the current. It's a drop of potential. Then it gets here. This is plus this epsilon. Well, that's not the epsilon. This the power source 1 E. Then I1 R1 again minus again here, and then you see you have I3 times R2 minus, and here they replace I3 by I1 plus I2, and then this is negative because it's from plus to minus, so it's E2. Okay, equals 0. So you have this equation, and then for the right hand loop, this has to be counterclockwise, has to be like this, and we have, okay, let's see, they start again in point B, so it goes this I2 times R1 minus, then again this E2, then I2 times R1 minus, and then again these 2 terms like the previous one, and then you have like 1. So in the end you get this, you punching all the numbers, and you get to this, and you have this one. So you have two equations with 2 unknowns, so you just can solve it. Okay, so this is one of the things you have to have very clear, which is all the Kirchhoff rules. Okay, hope you understand. If you have any questions, just tell me in class. Okay, bye.